Staring down a massive list of all 23 software design patterns often feels like a giant mountain of memorization. But we can ignore the list for now, because every pattern fits into a single 2x3 grid. Learn this map first, and every time you meet a new pattern, it automatically slots into its logical place. Thinking in terms of location and category replaces the need for brute force memorization. Design patterns are simply battle-tested, repeatable solutions to the complex engineering problems you will hit again and again. We can organize all 23 of these solutions by answering two fundamental questions. Those two questions act as the X and Y axes of our map: purpose and scope. The first axis is purpose. The creational column handles how new objects are instantiated. The structural column governs how classes and objects are composed. Finally, the behavioral column dictates how separate objects communicate. Any coding problem you face falls into one of these three buckets: how you create things, compose things, or how they talk to each other. The second axis is scope. This defines where the code's flexibility actually lives. Class scope patterns achieve their flexibility through inheritance. Because this relies on the inheritance tree, the structure is locked in at compile time. Object scope patterns achieve flexibility through composition. Their behaviors can be swapped out while the program is actively running. Most modern patterns are object scope, because engineering generally favors dynamic, runtime flexibility. Cross the purpose and scope axes together and you generate a matrix. Every one of the 23 patterns lands perfectly inside exactly one of these 6 cells. This grid acts as a mental filing cabinet, ensuring you never lose track of a pattern's function again. To see how this map works, let's look at 4 landmark patterns that cover the majority of real-world needs. Strategy is a behavioral object scope pattern. It allows you to swap different algorithms on the fly at runtime. Observer is also behavioral and object scope. It manages communication by broadcasting updates from one publisher to many subscribers. Decorator sits in the structural object scope cell. It adds responsibilities by wrapping objects in layers rather than using rigid inheritance. Finally, the factory method is creational and class scope. It uses inheritance to handle object instantiation while keeping the specific logic hidden. These 4 examples demonstrate the grid's logic, covering the most common hurdles you'll face in development and technical interviews. Now we can look at the complete landscape. All 23 patterns fit into the mental model we just built. When you internalize the map rather than a list of names, every new pattern already has a home before you even study it. Use this cheat card as a reference for the logic we've covered today. Hit subscribe, and we'll explore every individual cell on the map together.